homework time. Here we go. Yes, homework time. All right, well, let's start by putting your name at the top of your paper. Make your deal. I'll put my name, and you put yours. And you write today's date, and I will write today. There we go. All right, so you'll be glad to know that lesson 15 is just kind of more of the same. It's subtracting, where you might need to decompose into smaller units. For shorthand, we usually say regrouping across more places, upwards of even 6 places, subtracting from 1 million, for example. All right, so let's dive right in. I'm going to assume you know how to subtract. Good. All right, you can. All right, good. All right, so let's do this. If we have 6, we cannot so simply and blithely take away 8. No, you will not be surprised to hear that we need to regroup. So we go over to the tens place. 5 we will leave 4, and the 10 we bring to the ones place with the 6 already there. So now we have 16 to subtract the 8 from. Okay, great. And that leaves, yeah, you know your doubles, that's 8. And now in the tens place we have 4 minus 3, which we could do no problem. Again, 6 minus 8 is not happening. Okay, so we'll go to thousands place. Take 1,000 from there to decompose, leaving 8. And over here that will be 10 hundreds with the 600s already present in the hundreds place. And still you'll find that 16 minus 8, yes, is 8. And then in the thousands place we simply have 8 with nothing we're subtracting from it, so 8,818. Great, let's go on to B. 6 minus 0. Yeah, hey, there's something we can actually do. It's 6. Good. All right, now 5 minus A, however, yes, is going to get us going over to the hundreds place to regroup one of those hundreds, leaving 5. Comes over as 10 tens with the 5 tens already there. Gives us 15 tens minus 8 tens leaves. Do you know that one? Yep, good. 7. And then we have, again, we're stuck with this 5 minus 8 nonsense. All right, go over to thousands place. We're going to decompose one of those thousands, leaving 8. And it'll come over to the hundreds place as 10 hundreds. It's 5 already there. Is 15 hundreds minus 8. We just did this. It's still 7. And now we can cruise right on through. 8 minus 5 we know is, that's right, 3. Let's place that comma while we're here. And then 5 we're not subtracting anything from, so it is 5. Lovely. And now here let's look at C. We have 6 minus 9. You know right away we need to regroup, so we go to the tens place. And we will decompose one of those tens, leaving 4 tens there. And bring the 10 over as 10 ones with the 6 ones already in the ones place. Now we can do 16 minus 9 leaves. That's right, 7. But 4 minus 8. Confound it. Let's go to the hundreds place. From the 6 we will use one of the hundreds, leaving 5. It'll come over to the tens place as 10 tens. With the 4 tens already present. It's 14 tens minus 8 tens leaves. Another one, 14 minus 8. That's right, 6. Okay, and now here again. Oh, they're going to make us work tonight, baby. All right, 5 minus 9. Yep. Head on over to the thousands place. And now we will use one of those thousands, leaving 8. Decompose it to the smaller units, to the hundreds, as 10 hundreds. With the 5 already there is 15 hundreds. Minus 9 hundreds leaves, that's right, 6 hundreds. And look, more to do, yes. We can't take 8 from 9, so we head to the 10,000s place. And using one of the 10,000s, leaving 4, we bring it over to thousands place as 10,000s with the 8,000s already present in the thousands place. It's 18 minus 9 leaves All right, 9. Let's place the comma while we're there. All right, and you will not be surprised to see that we cannot take 7 from 4 without decomposing here. So the 7 will leave 6 in the hundred thousands place, which comes over as 10 10,000s with the 4 10,000s. Already there's 14 10,000s minus 7 10,000s leaves. Right, 14 minus 7. Yep, 7. And then whew, we catch some break here in the 100,000th place. We kind of had to. All right, 6 minus 5 is, yes, 1. Woo! All right, let's head on to DEF, D-E-F. Yes, y'all, here we are. D-E-F. Let's dive right in. 0 minus 0. Oh, they have mercy on us. All right, that's 0. But here we go. 5, yes, minus 7. We need to. You got it. Let's regroup here. From the 100 we have, we will leave 0. So we know we're setting up for some work there. We bring it over as 10 10s with the 5 10s already present is 15 10s minus 7 10s. We just did this up above, right? That leaves 8. 8 and 7 are 15. And now in the hundreds place, we know we cannot take 3 away from nothing. So from the 0, so we go over to the thousands place. To regroup that 4, we will leave 3 thousands. Bring it over as 10 hundreds to the hundreds place with the 0 hundreds that were already present. So now we can do 10 minus 3 is, yes, 7. And here again, you will find no surprise. Oh, you will be regrouping like a pro, my friend. All right, so we cannot take 6 from 3, so let's go to the 10,000s place. And we will use one of those, leaving 8 10,000s, which comes over as 10,000s to the thousands place with the 3 already in progress. So we now can subtract 6,000 from 13,000. 6 from 13. 13 minus 6 is, you know that one? It's a good one to know. It's 7. All right, yes. And we'll place that comma while we're here. And now, whew, breathe a sigh of relief. We can do 8 minus 6 is, yep, 2. And 2 minus 1, 1. Great. Let's hop right to E. Let's not waste any time. All right, don't get mixed up here. We cannot take 9 from 0. We need to regroup right at the get-go here. All right, and so this will leave 4 10s, which will bring over to the ones place as 10, joining the 0 ones that were there. So 10 minus 9, yes, is 1. Come as no surprise, we need to do something because we cannot subtract 8 from 4. So we go to the hundreds place, and we'll use that 100, leaving 0, to decompose into smaller units. So it will be 10 10s with the 4 10s already present. 14 minus 8. You know that one? That's right. 8 and 6 make 14. So 14 minus 8 is 6. And Lou, catch our breath, because 0 minus 0, yes, is 0. Okay, but no, we're right back to it. Here we go. All right, so we cannot take 9 from 4. So we go over to 10,000s place. Decomposing one of those leaves 8. And we'll bring it over as 10,000s with the 4 thousands already there. Now we can subtract 14 minus 9, leaving, yep, 5. While we're here, let's place that comma. And now we can subtract freely. 8 minus 3 is 5, yes. And remember, when we have something like this, 2 minus 2 is 0, we don't write the 0 there. It's confusing. Well, let's look at F. All right, so we're starting off with another 0 minus 0, thankfully, great. And look at that, they gave us another easy one, 5 minus 0. Yes, indeed is 5. We don't need to regroup there. All right, so now with the 1, though, we cannot subtract 4. So go to thousands place. Use one of those thousands to decompose, leaving 3. Bring it to the hundreds place as 10 hundreds with the 100 already there. Now we can subtract 11 minus 4 is 7. Good. And here, though, you see we cannot subtract 6 from 3. So we'll head to 10,000s place. use one of those 10,000s, leaving 8. Bring it over to the thousands place as 10,000s with the 3 already in progress. 13 minus 6 leaves, 7. We just saw that a minute ago over on D. We can place our comma while we're here, by the way. And now here, again, we cannot take 9 from 8, so we will regroup from that 2, leaving 100,000, which comes over to the 10,000s place as 10 10,000s with the 8 10,000s already there. 18 minus 9 leaves, that's right, 9. And then we have this 1 here in the 100,000s place, which we're subtracting nothing from, so it's 1. All right, we're blowing through this, y'all. Let's head out to, what do we have next? GHI. Let's go. And the old GHI trick, huh? All right, well, we're staring down the barrel of some zeros here. You see each of the subtrends here is 800,500 on all 3 of these. So we know we're going to be busy. So let's get busy. All right, we cannot subtract a 9 from a 0 without regrouping, so we will have to move across this 0 because it's no help to us to the 5. All right, we will use one of those 500s, leaving 4. Bring it here to the tens place as 10 tens. Okay, sweet, lovely. Wonderful, does nothing for us in the ones place. So one of those 10s, we'll leave 9 there, and we'll bring one of those 10s as 10 ones over to the ones place. Ah, lovely, now we can subtract. 10 minus 9 leaves 1, it's easy. 9 minus 8, you can do that. 1. We cannot take 9 from 4, however. So here we go, riding across those zeros again. All right, there's no thousands or 10,000s to decompose, so we head out to the 100,000s. From the 800,000s, we will leave 7 and bring over 10 10,000s. That is not doing us any good over here in the hundreds place where we left off. So we will take one of those 10,000s, leaving 9, and bring it over to the thousands place as 10,000s. And alas, that still does us no good in the hundreds place. So we will take one of those 10,000s, leaving 9, and bring it to the hundreds place as 10 hundreds. With the 4 already there, gives us 1400s. Now we can subtract 900s from 1400s, leaving us 500s. Excellent. And look how easy it's going to get now. 9 minus 9 is 0. And let's place that comma while we're here. 9 minus 7. Yeah, you know that too. And we're subtracting nothing from the 7. So there we are. Whew, good one. All right, let's look at what the Eureka Math hath wrought on H. Well, it starts off easily enough. 0 minus 0 is 0. 0 minus 0 is 0. 5 minus 5, also 0. We're on a roll. 0 minus 5. Did you want to say 5 or zeros? We gotta, yeah, you know what to do now. All right. Out to the 100,000s place we go, leaving 7 there, which is 10 10,000s we decompose, but that does nothing for us here in the thousands place, so we'll take one of those 10,000s, leaving 9 10,000s, and the 1 10,000 we decompose into thousands is 10,000s, right? 1 10,000 is 10,000s. So now we can subtract right on through. 10 minus 5 is 5. Drop that comma. 9 minus 4 is also 5. Lovely. And 7 we are subtracting nothing from. Good. Hey, let's see about this one here. Looks like we're going to have to do mega regrouping. Right off, we cannot subtract 4 from 0. So we know we have to head right over to that hundreds place and use one of those hundreds, leaving 4. Bring it over to the tens place as 10 tens, but we still have no ones we can subtract with. So we'll take one of those tens, leaving 9, and decompose it as ones. So one of those tens is 10 ones. Now we can subtract some. All right, 10 minus 4. You know you make 10 facts. 4 and 6 make 10, right? And now 9 minus 6 is 3. Good. Ah, confound it. We cannot take 6 from 4, can we? Were you thinking 2? We gotta do some decomposition here. We have zeros we need to move across to get to some actual values. And from that 100,000, we will leave 7 of those 800,000s and bring one of them to 10,000s place as 10 10,000s. But we are still hungering back here in the hundreds place. So those 10 10,000s, we will take 1, leaving 9 to decompose as 10,000s. And guess what? Still nothing happening in the hundreds place. So we need to take one of those 10,000s, leaving 9, and decompose it as 10 hundreds. With the 4 already present is 1400s. Now we can subtract 600s from it. Great. Do so. It is, that's right, 8. And 9 minus 6, get 3. Let's drop that comma. And 9 minus 7, yeah, we can do it. 2. And lastly, 7 minus 2 is 5. Okay. Well, now you'll see that on the flip side there, 2, 3, 4, and 5 are all our favorite word problems where we really get to think and use our subtraction skills the way people do in real life. Let's move on over. And for these word problems, we have the same directions that should look familiar by now. To use tape diagrams, we're going to do that, and the standard algorithm, which is the usual way of figuring things out to solve the problems below, and we will check our answers. Okay, so let's do that. Let's read this first one here. A fishing boat was out to sea for 6 months and traveled a total of 8,578 miles. In the first month, okay, because remember it was a total of 6 months, in the first month the boat traveled 659 miles. How many miles did the fishing boat travel during the remaining 5 months? And I love this problem because the whole 6 months and 1 month versus 5 months, basically we're talking about 2 sets of time, right? We have month 1 and then the other set of months. So don't get confused by the 6 months, 5 months, 1 month. We have 2 time periods we're dealing with here. First month and the remaining months. So let's just think of it that way and keep life as easy as possible. So our tape diagram, is the full length of it is going to be the full length of their little fishing expedition. And make a nice little bracket, or maybe a sloppy bracket, sorry. All right, so that's 8,578 miles. And now we see that the first time period, that first month, is just a small portion of it. So we'll write here 659 miles. Could have done a whole bracket there. Okay, and then I'll do a bracket for the remaining time period here. That's our unknown. That's what we're trying to find. Let's call it M for months at sea, poor fellas. Okay, so now we can see from the diagram, we take the whole and subtract the known part, we will find the unknown part. So the whole length of the fishing expedition was 8,578 miles. And the part we know is 659 miles. Okay, and so if we subtract these, we'll get the unknown part. And you can bet there'll be regrouping aplenty. All right, decompose like madmen. Here we go. We cannot take 9 from 8. I hope you didn't go and write 1. We cannot take 9 from 8 without regrouping. So we will go to the tens place, leaving 6 tens, and bring that 10 over to the ones place as 10 ones, with the 8 ones already residing there. 18 minus 9 leaves, yes, 9. Ah, happy day. We can do 6 tens minus 5 tens leaves 1 10. Alas, we cannot, however, take 600s from 500s without regrouping. So let's head to that thousands place, leaving 7 of those 8,000s, which comes over to the hundreds place as 10 hundreds, with the 5 already present there. So now we can subtract 6 from 15. 15 minus 6 is, yes, 9, and we're subtracting nothing there from the 7, comma. Okay, now we did the tape diagram and the standard algorithm to solve. Now let's check our answer. Okay, so if we take what we have for the two parts and add them together, we should get the whole. Okay, so if we say with the 7,919 and add that to the other part, the 600, ooh, that's in the wrong place, isn't it? You see what I did there? Ooh, gotta slow down, buddy. Put it in the hundreds place. 600, not 1,000, 659. Let's see, now we can do it right. All right, 9 and 9 make 18, good. And 1 and 1 and 5, 7, good. Really, this is a 9. We're going to make it look more like a 9. 9 and 6 make, all right, 15. Group that 1. 1 plus 7 is 8. Is that the length of the whole trip, what we started with? Yes, indeed it is. So remember here, this is our M. This is the remaining months. So you notice the directions actually do not have us write a statement. Can you believe it? But in a sense, we have here in numbers just by saying, well, that unknown part is M, but it's not in the instructions to write a statement. So by gum, let's move on to number 3. Quick, before anybody notices. Hurry. Now, here in number 3, let's see what we have. It says a national monument. Now, something like Mount Rushmore kind of thing. It's a national monument. Had 160,747 visitors during the first week of September. Okay, a total of 759,656 people visited the monument in September. How many people visited the monument in September after the first week? Okay, so again, just like with the last problem, don't get confused about how many weeks. We just basically have 2 time periods here. 1, 2. First week, rest of the month. That's it. We're just dealing with 2 time periods here. So our tape diagram will be nice and simple in that respect. Believe me, you will make some complex tape diagrams before this year is over, my little friends. Oh yes. So there's the whole stinking month of September. And for the whole month, we will bracket it. We have 759,656 visitors. And then for that first week, I'm just going to slice it there for the first week. Bracket. We have 160,747 visitors. Okay, so now to find the unknown here, I will use V for visitors. We simply see we can take the whole, subtract the known part to find the unknown part. So let's do that. All right, so we have 759,656, and we're subtracting from it 160,747. 47. Okay, and that will give us the difference between them, the unknown part. And let's dive right in. So we cannot take 7 from 6 without regrouping. So we go to the tens place. From the 5 tens, we'll leave 4 and bring 1 over to the ones place as 10 ones, conjoined with the 6 already residing there. Now we can subtract 16 minus 7, yes, 9. Okay, and 4 minus 4, hey, we can do that, 0. Here's the 6 minus 7 again. Oh boy, they make us work so hard. Oh. So from the 9,000, we'll leave 8,000. Bring it over to decompose into smaller units. Bring it over to the hundreds place as 10 hundreds with the 6 already there. Now we can again do 16 minus 7. We just did that. It's still 9. 8 minus 0. Cheerio. 8 minus 0 is 8. Let's place the comma while we're there. And now we see, again, we cannot take 6 from 5. So we'll head over to the 100,000s place and decompose one of those, leaving 6 100,000s. And the 100,000 we decompose will be 10 10,000s with the 5 10,000s already there. Now we can subtract. 15 minus 6 is 9, yes. And 6 minus 1 leaves, got it, 5. All right, let's jump right to the check. So we are saying this is our V, by the way. This is our number of visitors for the rest of the month of September. So to check it, we'll add the unknown part, the V that we just solved for, to the known part, and we should get the whole month of September. So let's give that a whirligig, shall we? All right, so 598,009, I said, 109. And if we add that to the other part, the 160,747, we should get the whole. And I told you this before, don't just go and write that number because you're wasting your time doing a check like that. You actually have to add and see what you get. So 9 plus 7 is, 16. 1 and 0 and 4. 5, good. And now 9 plus 7. Oh, we just did that. Yep, still 16. Good. And we regroup the 1. 1 plus 8 plus 0. 9. Drop that comma. 9 plus a 6. 15. Good. Group the 1, 1, and 5, and 1 make 7. Ah, yes, so we did get what we were supposed to. Everything checks out. Check, check, check. On to number 4. Now this question is lurking in the shadows. Shadow Software Company earned a total of $800,000 selling programs during the year 2012. Good job, boys. $125,300 of that amount was used to pay expenses of the company. How much profit did Shadow Software Company make in the year 2012? Well, you might remember from some economics you've had that if you take what you earn and subtract your costs, you will be left with profit. To make it nice and simple there. So if we take what they earned, the whole thing, drawing out our luscious little tape diagram here, it's a stick of gum. And bracket it. So they made $800,000. That's the whole cash drawer. Now the part that was expenses, section off a little part here, that was $125,300. What we're trying to find is the profit, which we will call P, of course. So you can see right from the diagram, we take the total they make, subtract their costs, we'll be left with the profit. Okay, so let us do that. All right, so we are taking 800,000 clams, not actual clams. and we are subtracting the cost they had, the $125,300. That will give us the profit. So let's do that. 0 minus 0 is 0. Again, 0. Now here, 0 minus 3, we cannot take 3 away from 0. So let's head up. We have to keep going. Keep going till we get to a value. Here it is, finally. All right, we have 800 thousandths to decompose. So we will leave 7 of them right where they were. And take one of those 100 thousandths and decompose it as 10 thousandths, which does nothing for us way down here in the hundredths place. So let's take one of those 10 thousandths, leaving 9 of them right where they were, over to the thousands place as 10 thousandths. And we're getting closer, but we're not there yet. So let's take one of those thousands, leaving 9 right where they were, and decompose it as 10 hundredths. Okay. So now we can subtract. We have 10 hundredths minus 3 hundredths leaves 7 hundredths. 9 minus 5, 4. Drop that comma. 9 minus 2, 7. Oh, sweet mercy. 7 minus 1 is 6. All right. Pretty good, huh? All right, so that's a tidy little profit there. Nice job, guys. And that's our profit. P equals that. Now to check it, if we take the two parts, they should add up to the whole. So that's the one we just solved for, $674,700. And if we add it this time now, add it to the other part, their costs of $125,300. We should get 800,000, but let's actually do the addition so it's worth our while. Because 0 plus 0 is 0. 0 and 0, again, is 0. 7 plus 3, you know that. Yep, 10. Regroup that 1. And now add up here, we see 1 and 4 make 5, and 5 more is 10. Regroup the 1. Drop that comma. 1 and 7 are 8. 8 and 2 are 10. Good. Regroup the 1. And now 1 and 6 and 1, yes, are 8. So everything checks out. So we're wrapping up here today. Let's move on to number 5. Who would have thought a seal named Bubba? Well, all right. As a Yankee transplant, I have no comment on that. Number 5 reads, at the local aquarium, Bubba the seal ate 25,634 grams of fish during the week. If on the first day of the week he ate 6,987 grams of fish, how many grams of fish did he eat during the remainder of the week? So you can see again, our tape diagrams can be very similar to the others. In fact, it's going to be identical with just a change in the numbers, really. We have the whole week, and we know the value for that, so we'll bracket it off. That is 25,634 grams. And by the way, they're introducing the idea of grams. We'll be studying all the units of weight and measurement in 4th grade, so you can see right here, when you're weighing something, you can weigh it in grams. And so a portion of that time, and again, don't get caught up in how many days in the week. We're just dividing the week into 2 parts, first day and the rest of the week. Just 2 parts. Okay, so that first day, he ate, must have been hungry that day, 6,987 grams. And what we're trying to find is the balance of the week, the remainder of the week. How much did he eat there? And we'll put F for fish, of course. All right, so obviously we have the whole, we have a known part, solving for an unknown part. We will subtract, and you can bet your bottom there will be regrouping aplenty. Or maybe regrouper, because groupers are kind of fish. Sorry, that was bad. Okay, so let's set up for our subtraction here. I always take a second. I do this and just like check to make sure I wrote down the numbers correctly. I look over there. Okay, yeah, I got the numbers right. Got to do that. All right. So now let's start off. We, unsurprisingly, cannot subtract 7 from 4 without some decomposition action. So we'll head over to tens place. From the 3, we will leave 2 and bring 10 ones to the ones place with the 4 already there. Now we can subtract. 14 minus 7 leaves. Yeah, you know your doubles, 7. However, we cannot subtract 8 from 2 without a little more decomposition. So in the hundredths place, in the 6, we will leave 5 and bring 10 tens over with the 2 already there. So now we can do 12 minus 8 leaves 4. Oh, cannot be surprised, can you? Yep, we cannot subtract 9 from 5, so we go to the thousands place. We're leaving 4 there. We bring over 10 hundreds. 15 minus 9. You know the one? Good. 6. And yet again, have to regroup here. So we will leave one of those 10,000s and bring over 10,000s to the thousands place with the 4 already there. Now we can subtract 14 minus 6 is 8. Good. And we are subtracting nothing from the 1. Drop that comma. Whew. All right. And as you know, to check, if we take what we got here for f, which was our unknown part and now is believed to be known, and add it to the known part, we should get the whole thing. So let's take that 18,647 and now add to it the other part, 6,987. Look, I lined up all the place values correctly. Good. All right, so let's add 7 and 7 make 14. You know those doubles. 1 and 4 and 8. 1 plus 4 plus 8. Oh, that's 5. 5 and 8. Another one. 13. Good. All right, we group the 1. And here I see a pattern. I see 1 and 9 make 10. 6 more is 16. Regroup that. 1 and 8 are 9. 9 and 6, 15. Lovely. And drop that comma. And now 1 and 1 make 2. And is that the number we had started with here? Yes, it is. Can you believe it? You did it. Magnificent. Homework time is over. See you next time. There's homework time to be timed into homework. The time of see you next time. Homework time.